My name's Bill Doak. It's my pleasure to introduce Dominic Caputo. Dominic is from Palo Alto. He's an engineer, and he's going to talk to us about their security offerings. So Dominic, I'll hand over to you.
Thank you very much. Can you guys hear me? All right, obviously today I'm going to be talking about our transit VPC architecture, where we can help with you reducing costs and strengthening your security posture within AWS. Now, a little bit of information about Palo Alto Networks. Is anyone here familiar with what Palo Alto Networks does as a company? That's great. So obviously, we're a next-generation cybersecurity company. We're fundamentally very different to the legacy technology that you would have seen within your data center over the last 10 to 20 years. Now, that's obviously based on ports and protocols, and we're fundamentally very different. So instead of looking at the layer 4, we're focused on the application layer. So we can identify the applications irrespective of the port and protocol. So we supplement what you get natively within AWS from a security group's perspective, but we can get extremely granular in terms of the applications that are traversing within your environments, controlling those applications, as well as having the ability to control traffic flows based on user identification. The other thing that we can do within the Amazon Web Services environment is obviously doing segmentation. If you're building a traditional data center and you're following that zero trust type of architecture, why wouldn't you be building that within your AWS environment? So leveraging our inline capabilities from our VM series, we give you that capability. So in a particular VPC, if you've got 3 different subnets, you can control the traffic flows between each of those subnets based on layer 7 identification. In addition to that, we also have the capabilities of detecting known and unknown threats. Now, from a known threats perspective, this is obviously leveraging things such as IPS to do antivirus, anti-malware, exploit prevention. Now, when I'm focusing on the unknown side of things, what I'm referring to is leveraging our threat intelligence cloud. Now, what does that actually mean? Say we've got a Palo Alto Networks customer in the United States as an example, and we've seen an unknown piece of malware before. It's a unique hash. It's brand new. It looks like a 0-day. That will automatically get sent to our Wildfire, which is our threat intelligence cloud. This is where we have our own custom hypervisors and bare metal analysis, where we will analyze that particular file to determine if it's malicious or benign. If it is indeed malicious, within 5 minutes, globally, we can update all of our customers. This is quite unheard of in the market from a cybersecurity perspective. The other capabilities that we have, we also give you the capability to centrally manage what happens from a policy and logging perspective. Obviously, the whole point of moving to somewhere like AWS is where you get that elasticity to scale out and scale in your environment depending on your requirements. As I'll go through in the further slides, we can talk about our bootstrapping capabilities as well as our centralized logging and policy enforcement points. When I start focusing on the AWS technology partner, what does that actually mean? What that means is that we've got a top-down management interaction directly with Amazon, as well as we've referenced architectures that have been built and validated by AWS. Obviously leveraging scripts that can do auto-scaling of our VM series, our web sandwich architecture that integrates the AWS ALBs and ELBs, as well as our VM series to do the granular layer 7 inspection and control. And as well as integrating things with Amazon Guard Duty. How many people here are familiar with Amazon's Guard Duty and what it can do? So as an example, if Guard Duty has identified a malicious IP address, we are automatically, through the use of dynamic address groups on our VM series firewalls, able to put that bad IP address into the group automatically through API. We have a whole benefit of other things that we can do with our dynamic address groups, like picking up tags of resources. So say you've got a web services tier, provided that you tag those resources correctly within our dynamic address group, we will automatically pick that up and add those IP addresses of those resources into that group. Now, how many people here are familiar with this particular slide, the shared responsibility model? Most people? Obviously, Amazon or AWS is responsible for security of the cloud. It's your responsibility to secure what you put in there. Obviously, your data and your apps. And this is where Palo Alto Networks can help you with that. Now, what I'm going to talk about is the transit VPC and the challenges with that particular architecture. Now, how many people here have 100 VPCs in their AWS environment? 50? 20? 10? 5? As you can start to see, you get a sense of the challenges of managing that sort of environment. If you've got 50 or 100 VPCs, how do you ensure that you've got consistent security posture and visibility across each one of those environments? Especially if you start provisioning VPCs with IGWs and things like that, how do you know from an operational perspective that you've got visibility across your entire enterprise? Ultimately, this becomes a challenge, and you need to provide a common set of controls to do that. And this is where leveraging something like the transit VPC will give you that capability. Now, if you think from a dynamic nature, within AWS as an example, if you've got a development team and you want to do some UAT testing or smoke testing a particular application, you'll spin up a whole infrastructure stack, whether it be 2 VPCs, 5 VPCs, 10 VPCs. Like I was saying before, how do you manage that? Especially from an operational perspective. If you're doing this manually, it could be prone to errors, right? Having that centralized visibility of all the traffic that comes inbound and outbound to your environment from VPC to VPC so that you can get that granularity so that you can control the traffic flows. Now, what are some of the alternate solutions to this transit VPC architecture? Obviously, you can have direct connects into your traditional data center environment. Hopefully, it's fully resilient. The problems with that is obviously the associated costs with that. You're obviously going to have to speculate your bandwidth requirements, which obviously adds to a lot of inefficiency because when you start moving workloads to the cloud, they can burst up and burst down, so it's very hard to gauge how much bandwidth is actually required. Now, if you're an organization that's focused on the cloud, it's traditionally cloud-centric. So what you could do, if you are deploying a load of VPCs in your environment, you can deploy VM series in each of those VPCs. Now that's perfectly fine to do that. Obviously, if you go down that particular path, you've also got to maintain that, and it's a costly exercise if you start talking in the range of 50 VPCs to 100 VPCs. Now, what is the transit VPC? Essentially, it's a hub and spoke architecture where in the transits, we have our VM series in different availability zones for resiliency. Now, it provides several important use cases. Obviously, it allows your private data center to connect into your AWS environment securely. It can also give you shared connectivity between your data centers. And the added benefit of this type of architecture, it gives you a cross-account access. So you can create different VPCs or spokes, as per this diagram, in different AWS accounts. Obviously, Amazon's best practices is to do segregation of duties so that in one particular account, you might have certain type particular workloads. It could be dev. In another account, you might have UAT. The added benefit of that is with this particular architecture, you can have that all leveraged from the transit or the hub. Now, if we drill down into the components of this type of architecture, obviously we have our Palo Alto Networks next generation firewalls, our VM series in 2 different availability zones for resiliency. They work in an active-passive topology. Like I mentioned before, they can be in a single account or multiple accounts. Now, if we start talking about the subscribers or the spokes, what we do is we leverage a VGW. Hopefully everybody here is familiar with the AWS VGWs that are available. This VGW will establish a IPsec tunnel to each of these VM series for resiliency. So if we have a problem in availability zone 2 or availability zone 1, we have that high availability to make sure that there's no service impact within your environment. Obviously, with the VGWs, they'll connect into the VM series through IPsec, and then we're leveraging a routing protocol called BGP over the top. So what that means is that as you provision additional spokes, everybody will know about it because the transit's going to be redistributing all of those routes. The added benefit is that as your environment scales, everybody will know about every other subnet within the environment. The other key important thing to remember is that everything will traverse the transit. So you get full visibility from a logging perspective and a control perspective of what VPC talks to which VPC. Now, in this particular architecture, we've got a transit VPC, hybrid, and an internet gateway, which is what we see a lot of customers doing. So if you think of it from this perspective, this is your traditional data center. You've got dual direct connects for resiliency, connecting into different VM series within the transit hub. Now, what happens if you've got an application that needs to be internet facing, you need to put load balancing so that you can scale up and scale in based on the demand? This architecture is great because it gives you that flexibility. Not only do you have the control in the transit, but depending on your particular use case, based on your workloads, you can actually deploy additional VM series in some of the spokes. What that means is that obviously if you're running IPsec, there's certain limitations with the VGWs. If you put an internet gateway directly on some of the spokes, that limitation will go away. So you'll be able to saturate the network. The other thing is that, like I mentioned, you'll be able to put load balancers in front of your web tiers so that you can scale out and scale in based on the demand. So it's a fully customizable solution. Now, how does it work from a high availability and a routing perspective? Obviously, in the VM series, we will inject a default route to Ethernet 1/1, which is our outside interface on our VM series that's facing the internet. From there, the enterprise network will learn the routes dynamically, like I mentioned before. So as you spin up more spokes, not only will the transit know about it, but as well as your MPLS environment within your organization. From there, the redistribution profile will redistribute the routes from here into the VGWs in each of the spokes. What that means is that it will obviously have all of the subnets for all of your organization, as well as what happens in this particular use case when you've actually deployed a VM series into one of the spokes. How does the routing work? If you're injecting a default route from the transit into some of these spokes, essentially you're going to have two default routes. This is where we will do a source NAT on the VM series. So in the previous example, I mentioned a load balancer. Any traffic that's originating from the load balancer, we will set up a source NAT to go out the local IGW that's in that particular spoke. Everything else that's outside of that will use the native default route, which is injected from the transit, and it will route the traffic back. So like I said to you before, it's fully customizable depending on your business use cases and your requirements. Now, what we've seen with a lot of customers, traditionally they would put a shared services into the transit. Now, obviously best practices is keeping the transit completely separate, where you've only got your VM series firewalls in there. What we've been seeing is a lot of customers are actually provisioning additional VPC dedicated for shared services. This is where you'd put things like your SIEM, your jump boxes, your monitoring tools, and things like that. The added benefit is that you can have all your internal secured resources in that particular VPC, leveraging the great capabilities of the Palo Alto Networks VM series firewalls. You can leverage things of obviously doing application ID and user ID. Now, in this particular example, let me put that into a bit of context. Obviously, most of the services that would be in that shared services are traditionally used by, say, IT admins. You can create a very simple policy that says traffic from this zone to this zone on this RDP application. So like I mentioned in the beginning, we identify the application irrespective of the port. And you can also add an extra layer to that and allow IT admins leveraging your Active Directory. So that way you can ensure that the people that are able to access that shared services VPC are actually from the IT admins within your Active Directory. Yep.
Can you just clarify which way the default route is meant to be in the subscriber VPCs?
In the subscriber. So obviously in the hub, it will inject it at its local IGW because the IGW is attached to the transit. Now, if you're talking about the spokes, if in the example that I was talking about where you would be leveraging a load balancer, traffic that's sourced from the load balancer, the return traffic will go out that local IGW. Right? And anything else, so if it doesn't come from the IGW and you've got other resources in there, it will use the default route that's injected from the transit. If you come over to our booth, I'm happy to go through it on the whiteboard with you, if that makes more sense. Obviously, this type of shared services would probably be relevant to a lot of organizations. Now, obviously, we can do a hybrid-based approach. Now, we have some customers who have dual direct connects from AWS into a co-location where they're using our physical appliances. Now, why are some customers doing this? Now, some customers are doing this because they want to leverage our single pass architecture that gives you that predictable performance. Now, a lot of companies, obviously some that sit into the government verticals as well as the FSIs, they have a mandate that they must SSL decrypt everything. Obviously, leveraging our physical appliances, like I said, you will get that predictable performance based on our single pass architecture, which I'm happy to explain in further detail if you come over to our booth, but leveraging the hardware capabilities to do the SSL decryption. Now, this can work in a hybrid model, right? You can have a co-location with physical appliances, and you can also integrate a VM series transit VPC architecture along that. So it's fully customizable depending on your particular use cases. Now, obviously based on what we've discussed, if you talk about scaling, yes, say I've got 5 or 6 VPCs, yes, I could probably build that manually. Yes, it would be a little bit of work. But what happens when your subscribing VPCs start to get into this range, where you've got 10, 20, 30? It can get very erroneous and very hard to manage. And how do you ensure that you don't have an overlap from IP addressing? This is where automation comes into play, leveraging a lot of the capabilities that we have within AWS. And it's not just about automation, it's continuous automation. Now, what we've built at Palo Alto Networks, we've actually fully automated this whole stack for you, provisioning the transit as well as the subscribers. Leveraging, obviously, some of these native components that you're probably all familiar with within AWS. I'm obviously not going to go through all of them, but the biggest ones that we've leveraged is obviously CloudFormation. Is everyone here familiar with CloudFormation, whether writing it or running it? Okay, that's great. So obviously the CloudFormation is obviously built by us. All you need to do is launch it within your accounts or different accounts. The other key things that we're probably using is obviously the S3 buckets to bootstrap our firewalls. That's where you would obviously set IP address of where you would talk to our centralized management platform, software updates, initial configuration, things like that. The other key ingredient to this type of architecture is the DynamoDB and Lambda. So the DynamoDB keeps track of all of the transit and subscriber VPCs and all of the subnets allocated. So this will stop you from spinning up additional subscribers to ensure that you don't have any IP address overlaps. Obviously, the smarts is where Lambda comes into play. We're using a subset of Lambda, which is what we call step functions, to obviously control the provisioning and deprovisioning of the subscribers' VPCs, and obviously leveraging things like SQS and SNS. Now, if we talk from a VM series perspective, obviously we're leveraging our VM series next generation firewall capabilities to obviously detect and prevent known and unknown threats and control applications and user identification. The bootstrapping, which I mentioned, leverages obviously the AWS S3 buckets, where we'll get the firewall configuration upon deployment and scaling, as I'll go through in a second. The other thing that's a key ingredient is our VM series API. As part of this automation process, not only do we spin up the transit and the subscribers, but we create that overlay network for you. So we will automatically create the IPsec tunnels between the VGWs and the VM series firewalls. We will create the redundancy for you, as well as create that BGP peering. This is all fully automated for you. You don't need to do anything other than running the CloudFormation scripts. The other thing to note is, obviously we're well known for our next-gen firewall platform from a hardware perspective. We've fully virtualized that and brought that into the AWS marketplace. Our API, RESTful XML API, has been on our platform since day one. So it's extremely mature. Anything that you can do from an interface perspective, you can fully automate and orchestrate from an XML API. And obviously Panorama is our centralized configuration and logging platform where you can obviously set centralized configuration, push that out based on device groups to the different transits or to physical firewalls and so forth. Now, if we're provisioning the transit account, now I tested this morning and it literally took me 10 minutes to provision it. To do this whole process and launch the transits and the subscribers can be done within 30 minutes, all of it fully automated. So if we look at the transit account, it's obviously built on CloudFormation. You'll set obviously that S3 buckets where you've got the bootstrapping configuration, as well as the details for the admin username for the passwords, for the firewalls, and the SSH keys so that you can actually SSH into it and log into it. In terms of the subscribing VPCs, there is a different CloudFormation script that'll obviously initialize the subscribing VPC. It needs to be run in every account. Now, like I mentioned earlier, a segregation of duties where you might have subscribing VPCs in different AWS regions or different accounts locally for segregation, right? So this script needs to be run in all of those accounts. It obviously sets up the IAM roles, the Lambda functions, and connects it to the DynamoDB. So when you're launching the subscribing VPC, you can actually get it to provision it, as well as spin up the VM series firewalls and create that overlay network. You could actually just provision the VPC by itself. So it will have no VGW or anything like that attached to it. Now, as I mentioned, if you initially provision it and don't create that connectivity to the transit, how do you get it automatically attached? Obviously, with the power of automation, as soon as you add this tag, subscribing VPCs, to that VPC and have a yes next to it, automatically we will pick that up. We will automatically provision the resilient VM series firewalls in the different availability zones, and we will create that overlay network, that IPsec with BGP running through that, literally by adding that tag. Fully automated, leveraging the power of the services within AWS. Now, as you can tell, as you start adding more and more subscribers, this is where you start to see the power of the automation. So there's one thing to note. Obviously, if you have an already provisioned subscriber, it cannot have a VGW or an IGW attached to that. So provided they're not there, all you need to do is add the tag and it will automatically provision the overlay network. Now, when we start to talk about scalability from a perspective, the amount of VPCs that connect into a single VM series firewalls, obviously you will come to a point in time where you will exceed the capacity of those devices. So when you're launching the automation scripts, there is a parameter called PA group, and that's where you'll specify the amount of subscribers paired to a pair of VM series firewall. So in this example, say you set it to 10. What happens when I want to add an additional, say the 11th N+1 subscriber? What happens then? As part of the automation process, we will provision an additional set of VM series firewalls. We will create the overlay network, which is BGP running through IPsec. And as you start to scale that out, all of the additional VPCs, based on the N+1 parameter that you set, will terminate on the new pair of VM series firewalls. So from a scalability perspective, you're in control of that. You might have high throughput workloads where you might say, actually, I only want 5. So instead of you having to modify those scripts, as you're provisioning the CloudFormation template, it's literally you putting that number in there. Now, it's important to note that we actually do the deletion investigations before we do the actual provision. So what does that mean? So say if you were adding this particular subscriber as an example, but prior to that, you were deleting this subscriber. We will actually delete that VPC first, then provision the additional one. Because obviously, if you're going down that particular process, you don't want it to spin up additional firewalls, connect that VPC, then remove it. So we do the deletion first as part of the logic within the CloudFormation templates. Does that make sense? Now, what are the benefits of the transit VPC architecture? Obviously, we're leveraging the power of Palo Alto Networks VM series to enforce consistent security across your AWS environment. We're centralizing resource connectivity, so any of the subscribers have to go through the transit. So from an auditing perspective, you can allow that traffic flow, provided that you allow logging, will give you that granular visibility. Also, you can do the controls in terms of controlling the traffic flow based on applications, applying things like threat prevention, and more importantly, you might want to do SSL decryption between certain workflows. We give you that flexibility per policy. So it's not a global tick box where I say, hey, I need to do IPS and it's enabled on the whole platform. You can do that per rule. We have many more capabilities that we're capable of doing. If you'd love to come over to the booth, we can go into these more detail. Things like obviously MFA, command and control, DNS sinkholing, all of that is available out of the box. Right? Obviously, reducing cost and complexity. From an operational perspective, if you've got ingress, inbound and outbound from the internet, VPC to VPC connectivity, your on-prem data center into your AWS environment, you've got that centralized choke point where you can get full visibility and control. Now, obviously, where do I get these automation templates from? If you go to this particular website, live.paloaltonetworks.com/cloud template, we have a multitude of resources that are available on this website. We also have the transit VPC architecture. We've got some AWS auto-scaling templates. We have our AWS web sandwich architecture, where we're leveraging the power of the VM series, as well as ALBs and NLBs within AWS. Plus, we've also got some great automation stuff, not only on CloudFormation, but Terraform and Ansible. So from a Terraform perspective, we have a provider within Terraform that can automate and orchestrate a lot of these capabilities, as well as some Ansible modules. So there's a wealth of resources there. So I urge you to go have a look at this particular website, because like anything, it's very difficult for you to try and build this automation. There might be some snippets in there that you want to actually strip out and put it into your own code. Because it's freely publicly available, you can do that. Thank you very much. Obviously, this is just one of our capabilities at Palo Alto Networks. This is our inline protections. We have other capabilities from an API perspective, which is our Evident IO platform, which is an audit and compliance tool. Plus, we have a next generation advanced endpoint product that looks at techniques on an endpoint. So if you'd love to get more information, please come over and see us at the booth, and we'll answer any questions that you've got.